So that wasn't going to work, but I just did, you take that away, you still have a 0.07 divided by 7, gives you a 0.013, not a 0.13. Okay, here's your amplitude. Now that makes sense, because what happened? This thing is swinging outward at whatever velocity I gave it, at 40 centimeters per second. It gets hit by something which slows it down to 5.7 meters per second. Centimeters per second. Okay? So it's going to slow down. It's not going to swing out a whole lot further than that 0.1 meter. And this tells me that, it doesn't swing out much further than that 0.1 meter. I wasn't thinking it would swing out even that much further, but if my numbers are correct, it does. So that's as far as it goes. Now we could go further with this into the simple harmonic motion. We could calculate the velocity at equilibrium. Now we can do that quickly. Velocity at equilibrium. Well, again, writing out more than probably necessary. But right there is again what we mean by the total energy. Equilibrium is measured, equilibrium is the x equals 0 position. It follows that at equilibrium, all your energy is in the kinetic energy because you got 0 here. So 1/2 mv squared equals E total. V equals the square root of 2 E total divided by the mass, which looks a whole lot like this expression, except it's E total divided by K. And look at the similarity in these two expressions and see how this one compares to this one and see why. Just think that through. It's very obvious. Okay? So this is going to be the square root of, let's see if I can do this one right, 0.0072 joules divided by the mass, which is 0.07 kilograms. Keep getting these 0.07s. Okay, well, we know how that's going to work out because the numbers are just coincidentally the same as they were here. That's because I used like 100 meters and 10 meters or 10 centimeters for my displacement, 100 meters for the length. Haven't traced that back, but I'm sure that's why these numbers came out the same. They will not in general. If I'd have chosen any other numbers, that wouldn't have happened. Anyhow, that becomes now 11.7 centimeters per second. Just coincidence of my choice of numbers. The numbers come out pretty much the same here. Okay. Also, if we want to get the velocity at any position, if we know x, then we can solve this for the velocity. Okay. If we want to know its potential energy at any position and know its velocity, well, we can do that. Okay, well, that's quite a bit about a lot of stuff that you need to know about simple harmonic motion in a context of a collision problem. So we got to hit both of them here. Okay, was that fun?
I guess so.
Let me get the camera.